All right, we are now at simplifying trigonometric expressions. We're going to take these longer string of trigonometric expressions and we're going to simplify them into either a whole number or one trigonometric function or a combination of both. So let's first of all talk about what we're going to do here. We are going to convert all of these identities into sine or cosine and then see if we get some cool kind of cancellation. Oh, I hate using that word cancellation because it's really simplifying. We're going to make things that, like if there's a sine divided by sine, that makes a 1. If we have a positive cosine and a negative cosine, that makes a 0 if we add them together. So I need to really hammer home some canceling no-nos. I mean, these are bad habits that you might have created, or you might just think that, oh, I'm sure I can do this. Let's say you have an x over x plus 1, and you say to yourself, well, I've got two x's above each other. I'm just going to cancel these out. No, you cannot do this. This is not a permitted activity because the binomial cannot be just simply canceled out, here and here. Now you might think to yourself, but I'm sure I've done that before. And what you might have done is you might have done, a bunch of monomials in the numerator and monomials in the denominator, like 3xy over 7 xy, and you canceled out the xy's. Well, that's fine because there's no pluses or minuses. It's just basically one term over another, and you can do that. But with binomials, no way you can do that. I've seen this as well. This is a common mistake. If I have x plus 1, and let's say x minus 1, I've seen people just try to cancel out the x's, no, you can't do that. Or they say, well, I can cancel out the 1s, and like, no, what is that going to leave? 0 over 0, an undefined expression? I mean, like, or just plus over minus. I've been around this game so long that I've seen this before. Please do not do that. And then you might think to yourself, well, I guess he really hates us canceling variables. But if I have something like this, I can just, cancel the 2's out here. Obviously, that would be good, right? Just cancel the 2, see the 2 and 2. No, you can't do that either. You cannot do that. This is a no-no. You cannot just cancel part of a binomial with another part of a binomial or another monomial. You can't do that. But then you say, but I really feel like this is possible. If I have 3x plus 1 and in the denominator I have an x, then obviously I should be able to cancel out these x's, right? Wrong! No, you can't do that either. You cannot do that. This is illegal. Now, what you could do, though, if you had 3x plus 1 all divided by x, what you can do is you can write that as 3x over x, and then 1 over x, which then gives you 3 plus 1 over x. But 3 plus 1 over x is not equivalent to 1 here, which is what you might have thought, or 3 plus 1. Even worse, right? I mean, I can cancel the x's out and not the number. There's just so much wrong with that. I mean, substitute some numbers in for x in each of these 4 circles that are lined in red, and you'll see that your cancellation is just not going to be appropriate. So please do not cancel part of a binomial with another part of a binomial or monomial. So you might say, well, when can I cancel? Well, you can cancel in a situation where, let's say I have 4 and then I have x plus 2, and in the denominator I have x plus 2. Now here's a situation where I can cancel these. This is completely appropriate to do so because this x plus 2 in the numerator is removed from the 4. If this started out as 4x plus 8, we could just factor out the 4 and get this x plus 2, and now a perfect binomial cancellation can occur. All right, and yes, that is legal in green. What I did in green is legal. What I did in blue all the way through here is legal. But anything up here, these are your canceling no-nos, and you will have the urge to do it because sometimes you'll see a problem and you'll want to just get rid of the x's and say, hey, I'm done, but you're wrong. You can't do that. So we are going to take the next part of this video, and we are going to show you by jumping in. We're just going to jump in to some trig simplifications. And this is like learning how to play chess. I mean, in the previous page, you have all the motions of all the chess pieces. That first page that we did, that has all of this stuff on it, that's how the chess pieces move. Now we're just going to get into playing, and the first time you play a game, you're going to lose, and you might lose badly. But through playing the game over and over and over again, you will actually get better at it. And the challenge is to kind of like watch me do the problems, and then if you'd like to, try to do them yourselves, but, you know, cover up the answers and, you know, give yourself some time, because you're not going to memorize all these techniques. But the best thing you can do in each of these problems is turn everything into sine and cosine. That is the super strategy here. But before we do that, let's take care of this negative theta. This negative theta, this is a tangent, okay? So according to the odd-even functions, the tangent of theta, I can pull that negative out and move it in front, but I'm going to move it in front of this entire problem. So now I have cosecant theta times tangent theta times cosine theta with a negative in front. So the next thing I'm going to do is turn each of these non-sine or cosines into an expression of sine or cosine. Now, the cosecant is a reciprocal function of sine, so I'm going to have 1 over sine of theta. Okay, my negative's still out in front. Then I'm going to multiply that by tangent. According to that quotient function, or quotient identity, we have sine theta divided by cosine theta. And then we're going to multiply by what we have left here, which is our cosine theta. It's in the numerator, so we can put that over 1 to help you a little bit. And now what we get to do is something you've been told to do. It's called cross-canceling. I like calling it simplification still, because canceling implies a 0, and sine divided by sine is just 1. Now you can cross those out and just leave them that way, but please note that this is now a 1 in the numerator and a 1 in the denominator. So this is now negative 1, and this is now 1 over cosine theta. But you can see that these get canceled as well, or simplified, and this is now the sine over cosine, now being fully simplified, is a 1. And now the cosine is now a 1, so now it's 1 over 1, which is 1. So my answer to this problem is negative 1. This is simplifying trigonometric expressions. We started off with an expression here, and then we get an answer of negative 1. Now you'll sometimes see me draw an arrow with an equal sign to it. I should probably avoid the equal sign because this is not an equation. Or sometimes I will just draw an arrow showing where we went from and where we went to. These are not equations, so if someone ever says, oh, what I did is I multiplied this by both sides, there's no both sides here. There's just one side, which is the expression. So there is no second side. You just have to take what you have in front of you, and you have to use it. Now let's look at problem 2. Problem 2 has a sine squared theta, and a cosecant theta and a cotangent theta. I don't have any negative thetas, so I don't have to use my odd-even properties. What I'm going to do, though, is I'm going to turn all of my not sine and cosines into a sine or a cosine. So let's turn that cosecant into 1 over sine. Okay, that's a 1 over sine theta. And then my cotangent is going to be, and I should put some multiplication signs here. My cotangent is going to be my cosine theta over sine of theta. Okay, so if we put this over 1, we now can do some cross-canceling. You can also, if you'd like to, combine these, because sine times sine is sine theta squared, and we can move that to the inside if we'd like. All right, so now what we have is we have the sine squared theta. This is our original blue sine squared theta. And now we have this multiplied by a cosine theta, but there's now divided by a sine squared theta, and thanks to cross simplification right there, see, I'm trying to take the word, I'm trying to say simplify more than cancel. So thanks to this cross simplification, we have now cosine theta. Now, you might be saying to yourself, well, I didn't write down all those steps. I actually got to the answer much quicker than you, Mr. Anderson. Well, I mean, yeah, these are your notes, so I kind of write things out a little bit more than you probably should. But on the paper pencil test, I would like you to write out more steps than fewer, although on the XYZ homework, you can skip steps to your heart's content as long as you get the problem right. So now I have these two multiplied by each other, and then this addition problem actually encompasses like these two pieces here. All right, so what we're going to do is we're going to like process this subtraction of this, or actually this negative theta. Now cotangent negatives get moved out to the front, so that's going to turn that into a subtraction sign, and cosine negative theta is the same thing as just cosine theta. So the problem gets rewritten as such: secant theta, cotangent theta, minus, and remember the minus came from the negative theta, the odd-even property, move that out to the front, and the cotangent theta is now, hey, it's now a just a normal theta, not a negative theta, and the cosine theta is now a normal theta, not a negative theta. Awesome. So here we now are going to convert every single non-sine or cosine into a sine or cosine and see what we get. And for those of you who think we can just subtract these cotangents, nope. These two get multiplied and these two get multiplied, and then we can do some subtraction. Thanks to order of operations, the subtraction does not go before the multiplication. So secant is going to be 1 over cosine theta. And cotangent is going to be cosine theta over sine of theta, thanks to the reciprocal property and the quotient property, or identity here. Then what we have is this cotangent theta, again, is going to be cosine theta over sine theta. And then over here we have in the numerator cosine theta. All right, so let's see what we got here. We are going to take this cosine and cosine, right? Okay, so I got cosine and cosine. Simplify that. All right, so now what I have is 1 over sine theta. Now here I have subtract cosine theta, cosine theta. This is cosine squared theta over sine theta. Now you might be thinking to yourself, okay, what do I do here? I got 1 minus sine theta minus cosine squared theta over sine theta. Well, what I'm going to do is, since I have common denominators, I'm going to rewrite the numerator as a binomial. Here's 1 minus cosine squared theta over sine of theta. What do we do now? Everything's in terms of sine and cosine, but look at that numerator, 1 minus cosine squared theta. Let's go check our front page here. 1 minus cosine squared theta. Oh look, 1 minus cosine squared theta is part of our Pythagorean identity triple here. And 1 minus cosine squared theta is equal to sine squared theta. And that means that this expression, this fraction, now becomes sine squared theta over sine of theta. And since I have a sine squared theta in the numerator and a sine in the denominator, that's like saying sine theta squared divided by sine of theta. So we have a power reduction here. This gets reduced to the power of 1, and this gets simplified. Sine of theta is your answer. Wow, right? Didn't see that coming, but that's why you're watching. You watch a good chess player play chess to get better at chess. And in fact, I do this a lot on Twitch TV. I watch people play strategy games on Twitch for the video games that I enjoy that will let me and make me get to be a better player. All right, and so far those games are pretty much Hearthstone and Overwatch. So let's go and check out problem 4 here. So we got tangent plus cotangent over. Okay, so here's what you just want to do. It's like, oh man, what I want to do is I want to cancel that cotangent and cancel that cotangent, and my answer is tangent. But you can't do that. You can't just say bam, bam, and be done with tangent as your answer. No. Cannot do that. What you have to do is you have to stretch this out and say, okay, I've got tangent theta divided by cotangent theta plus cotangent theta divided by cotangent theta. Okay? We can do some simplification here, okay? We can do this, but this doesn't make a 0. This, in fact, makes a 1. So now I have tangent theta over cotangent theta plus 1. Okay? Now, what does this mean? What it means is that maybe I can turn everything into sine and cosine and get some cool value here, but in fact, there's a pretty fast way to do this. Instead of using sine and cosine, I can remember that tangent is equal to 1 over cotangent. So look at the way I'm going to write this. Now again, there's more than one way to do this. Turning this into sine and cosine divided by cosine over sine will get you the same answer, but look at what I'm going to do. This is kind of like watching a pro here. I'm going to say tangent theta times 1 over cotangent theta plus 1. Okay, so all I've done is I've taken that cotangent theta in the denominator and made it into a 1 over cotangent theta. If I multiply top times top, bottom times bottom, I get the same thing. All right, now, we know from the reciprocal property here that 1 over cotangent theta is now just tangent theta. Whoop, don't need the square there yet. All right, got a little ahead of myself there. All right, if you see where I'm going. Now, this green tangent theta, I want to show you where it came from. You see this is this. Okay, so the first tangent theta stayed the same, the plus 1s are staying the same, and the 1 over cotangent theta is the same thing as tangent theta. Well, this means if I got tangent theta plus 1, now I have tangent theta squared, which is the same thing as tangent squared theta plus 1. And then now I look back on my, let's look back on my properties here, is tangent squared theta plus 1. You see it? It's 1 plus tangent squared theta. I can rewrite that because of the symmetric property, but I don't, or actually the commutative property, but I don't need to. You can see that that is my final answer of secant squared theta. Right, that is fully simplified, the most simplified it can get. Now you probably thought, well, Anderson, the directions said to get it down into a single trig function or a whole number or both. Yes, this is both, but this is better. The shorter you make it, the better. And you're still feeling like, oh boy, every single time you show me a problem, it's something new. I know, it's I'm building up your toolkit for solving these problems. And having been exposed to these problems now, you should be able to kind of like help yourself when you do the actual problems. And now, when you see parentheses, your algebra brain says distribute. Oh, distribute. And I'm telling you, before you distribute, let's, for this problem, do exactly what I said to do, is just turn everything into sine and cosine. Okay, now this cosine theta stays exactly the same, but the cosecant is 1 over sine theta. And the secant is 1 over cosine theta. And the cotangent is cosine theta over sine of theta. All right, now, on the outside was this cosine of theta in the numerator. Now what I'm going to do is I'm going to distribute it. Okay, I'm going to distribute it now because distributing the cosine first would have made this look pretty muddy. All right, so I am going to do the distribution in blue. Okay, bloop and bloop. And what this gives me is cosine theta over, the denominator was sine of theta minus, and my numerator here is cosine theta, and my denominator here was sine of theta minus cosine theta sine of theta. Oops, I'm sorry. I made a little mistake here. Let me erase that. This second fraction was cosine theta over cosine theta. All right, now, let's see what kind of simplification you can do here. Okay, so the first simplification is that you can see that this cosine theta over cosine theta, that there makes a 1, okay? That's 1 divided by 1. So now what we have here is we have cosine theta over sine theta minus 1 minus cosine theta over sine theta. Now do you see what we're going to do next? Sometimes I've seen teachers say, okay, now that's this in green right here, that's cotangent, and this in green right here, that's cotangent, and so we have a cotangent minus cotangent, but literally, folks, these whole expressions make 0. This is probably when I can say cancel. The cotangent, or cosine over sine, minus cosine over sine, that makes 0. So my answer in this problem is -1. Yeah, that's it. This is my answer right there, because this and this simplify to nothing, because it's really, cotangent theta minus cotangent theta. Now you might have said, well, why'd you make me convert it in the beginning? Because in the beginning you don't know what's going to happen. In the beginning we don't know, so that's why we do it and we try it, and if it works, great. If it doesn't work, well, we can just keep trying. And this was your first exposure to simplifying trigonometric identities. We're going to do it again. We're going to have 4 more problems in the next video, where you'll see some other crazier techniques in simplifying trigonometric expressions.